Right. So good afternoon, guys. So today we have to complete the balance area of linear programming. So last week we completed the linear programming question, including drawing the graph, feasible region, ISO contribution line, identifying the optimum production point, solving the optimum production point, and getting the optimum production plan. If it's if you have two resource constraints at the optimum point, as well as one demand and one resource constraint at the optimum point. And we learn the calculator method also, and then calculating the maximum profit, right? So we did two questions. So today we have to do the balance part of linear programming, that is two areas called slack and shadow pricing, right? So before we start, I want you all to go through the two questions that we did last week, right? The example, again, go through all the steps, and then the next question that we did, which is the chapter end question number 3, right? So I want you all to go through it quickly because slack and shadow pricing will be directly related to that. Okay. So take few minutes and quickly go through it, guys. Right. So let's start, guys. What do you mean by slack, guys? Yeah, what do you mean by slack? So basically, in simple terms, slack is the part of a resource that is underutilized, right? Slack is a part of a resource that is underutilized, right? The underutilized part of a resource is called the slack. For example, let's say you have 100 kilos of raw material, right? Right? You have 100 kilos of raw material available with you, and you're using only 80 kilos. You have 100 kilos of raw material available with you, but you are using only 80 kilos. In that case, how much are you underutilizing the resource by? You are underutilizing the resource by 20 kilos. So therefore, slack is 20. Clear? Slack is 20. So basically, slack is the part of a resource that is underutilized. Clear? So that is slack. So um, so that is slack, guys. So let's learn how to calculate slack, right? So if you go through the note here, I have said this is the amount of a resource that is underutilized when the optimum plan is implemented, right? So before we go through the balance part of the note, let's understand how to calculate the slack. So here I will say slack is the underutilized part of a resource. So let's go through this example. Calculate the slack for the example of tablet company. So that's why I told you to go through the note. So tablet company is this question, right? This question that we did. So let's calculate the slack. Right. So now in this tablet company question, how many resources are there, guys? Now slack is only for a resource, huh? It's not for a demand, it's only for a resource. So how many resources are there in this question? There are how many resources? There are three resources: build, program, and test. Three resources are there: build, program, and test. Build, program, and test. So basically, guys, like I said, slack is the underutilized part of a resource. So to understand how much of a slack we have, we need to first of all check how much of the resource are we underutilizing. How much of the resource are we underutilizing? For example, if we have 100 kilos, if how much of it are we using? Let's say we are using 80 kilos. Then the underutilized part or slack is 20 kilos. So first we have to calculate that. Now, all three resources, build, program, and test, right? All three are used. Yeah, all three are used to produce both X product and Y product, right? So we have to go by the two products, product X and product Y. Product X and product Y. So first let's take product X. So product X, so basically guys, what we are trying to calculate here is we are trying to calculate how much of the resource are we utilizing, right? So if we take product X, right, to produce 1 unit of product X, how many minutes of build do we require? So first basically guys, what I am going to do is I am going to show you all how to calculate the slack for build resource, and I want you all to calculate for program and test, right? First I am going to show you all how to calculate for build. So focus and look at this. So how many minutes are to produce 1 unit of X, how many build minutes are required? Minutes per unit. Yeah, how many? Look at the question. To produce 1 unit of X, we need 24 minutes of build. Right? That multiplied by number of X units produced. So how many X units are we going to make, guys? From where can I get that? You have to go to the optimum production plan, right? Come to the optimum production plan. See, optimum production plan is 20,000 units of X, 66,000 units of Y. So we are going to produce 20,000 units of product X. Yeah. So that will tell us total usage for product X, right? So that will tell us the total amount of build minutes that I want for product X. So 24 minutes for 1 unit multiplied by 20,000 units. 480,000 minutes, right? So to produce the 20,000 units of product X, I need 480,000 build minutes. Clear? Any questions on that? Right. Next, product Y. Minutes per unit. To produce 1 unit of Y, how many build minutes do I need? 20. Right? I need 20 minutes of build. And according to my optimum production plan, how many units of Y are we going to produce? Go to the check the optimum production plan, 66,000 units. 66,000 units. So if that's the case, what's the total usage for product Y? 20 minutes for 1 unit multiplied by 66,000 units. 1,320,000 minutes. So that's a total usage for product Y. So the total usage for product X is 480,000 minutes. For Y, it is 1,320,000 minutes, right? So then I will take the total usage. That is by adding both X plus Y. By adding both X plus Y. So that I need 480,000 minutes to make product X. I need 1,320,000 minutes to make product Y. Total of 1,800,000 minutes. So in total, I am using 1.8 million minutes, and total resource usage 1.8 million, total resource availability. So I am using 1.8 million minutes, and how many minutes are available? Check. It expects that skilled labor will be 30,000 hours, 1.8 million minutes for build. So I have 1.8 million minutes, and I'm using the entire 1.8 million minutes. Clear? So then how much of slack do I have? Slack will be 0. Slack will be 0. So that is how I calculate slack. Clear? Any questions? Are you clear on how to calculate slack now? Yeah. So now I calculated for build. So what I want you all to do is now take down the slack calculation for build and calculate the slack for program and test. Do it. Calculate, take down for build and calculate for program and test. Right. Shall we go through? So program. So if we take program, program is also used to produce X and Y. So to produce 1 unit of X, how many program minutes do we require? 16 minutes. Right? Multiplied by 20,000 units of product X we are going to make. Right? So for 1 unit, if it's 16, for 20,000 units, it will be 320,000 minutes. So I need 320,000 minutes to produce or for the usage of product X. Okay. Then let's take product Y. To produce 1 unit of product Y, how many program minutes do we need? 14. And we are going to produce 66,000 units of product Y. So that means how many minutes do we need? 14 minutes for 1 unit multiplied by 66,000 minutes, 924,000 minutes we need for product Y. Clear? So in total for the company, we need 320,000 minutes for product X, 924,000 minutes for product Y. So in total, we need 1,244,000 minutes in total for both X and Y. So I need 1,244,000. I have how many minutes? I have 1,680,000 minutes of program, right? So I have 1,680,000 minutes. So that means my slack is how many minutes? I have 1,680,000, but I'm using only 1,244,000. So I have a slack of 436,000 minutes, right? 436,000 minutes, right? So if I just convert this into hours, so that uh, it's easier for us to talk in hours than minutes. So if I convert this into hours, 436,000 divided by 60, that is 7,267 hours. Okay, 7,267 hours. Then let's take test. To produce 1 unit of X, how many test minutes do we need? 10 minutes. And we are going to produce 20,000 units of product X. So for 1 unit, if it's 10 minutes, for 20,000 units, I need 200,000 minutes. So I need 200,000 minutes for product X. Then product Y. To make 1 unit of Y, I need 4 minutes of test. And I'm going to make 66,000 units. So for 1 unit, if I need 4 minutes, for 66,000, I need 264,000 minutes, right? So in total, I need 200,000 for I need 200,000 for X, 264,000 for Y, total 464,000 minutes. I need 464,000. I have how many minutes? For test, I have 720,000, right? So I have 720,000 minutes, but I am using only 464,000. So my slack is 256,000 minutes, right? So 256,000 minutes in hours will be 4,267 hours. Right? So this is your slack, right? No slack for build. You have slack for program and test. 7,267 hours of slack for program, 4,267 hours of slack for test. Clear? Any questions? So basically, I have extra 7,267 hours of program that I'm not using. And I have 4,267 hours of test that I'm not using. Clear? Any questions? Right. Now, what I want you all to do is, so which resource has a slack? Program and test. Which resource doesn't have a slack? Build, right? So keeping that in mind, go to the graph that we drew. Go to this graph. Right. So in this graph, guys, right, in this graph, what is the optimum production point? The optimum production point is point D, right? Now at point D, what are the resources that are intersecting? Now at this optimum point in this example, there is one demand constraint and one resource constraint that is intersecting. So what is the resource that is falling on the optimum production point? Yeah, what is the resource that is falling on the optimum production point? Build, isn't it? See, build, right? And what are the resources not falling on the optimum production point? The resources that are not falling on the optimum production point are program and test, right? So tell me guys, build is the resource that is falling on the optimum production point. And for build, what is the slack? What is the slack? 0. Program and test are the resources that are not falling on the optimum production point. And for program and test, what is the slack? Is there a slack? Yes, there is a slack. So the resource that is falling on the optimum production point build, there is no slack. The resources that are not falling on the optimum production point program and test, there is slack. So basically guys, what you need to understand is, right, in very simple terms, if a particular resource, listen to this carefully, if a particular resource falls on the optimum production point, that resource will not have a slack. That resource is fully utilized and will not have a slack. But if a resource does not fall on the optimum production point, that means that resource is not fully utilized and it will have a slack, right? That is what you're seeing from that is what we proved from this example. Clear? So if a resource falls on the optimum production point, it will not have a slack. It's a fully utilized resource. It's a scarce resource. But if a resource does not fall on the optimum production point, then it will have a slack. It is not fully utilized. Clear? So say okay, right. Take this note down. Nah? Take this note down. Okay, right. Now, next thing to understand is, guys, okay, so there is a slack. What do we do with slack? What do we do with slack? Right? So slack is basically, guys, an underutilized resource. That means if you take this example now, you have 7,267 hours of program department and 4,267 hours of test department that you have that you're not using. Even though you're not using, you're still paying your employees, right? You're paying the employees, but you're not using, right? So it's a cost, but there is no return. So what you can do is, guys, you can rent this out to another company, right? For example, let's say there is a company, right? There is a company who does not have enough capacity, right? So company in the same industry that does not have enough capacity, right? So if there is a company who does not have enough capacity, right, what they can do is, right, even though they want to produce, they don't have capacity. That means their factory, it's fully utilized, right? They can't produce anymore, right? So then what normally companies do is they outsource the production. They outsource the production. So in industry terms, it's called subcontracting, right? Outsourcing the production. If you don't have enough capacity, if your factories are fully utilized and you don't have enough capacity to produce more, then what you do is you outsource the production to another company, right? And they will do the order on behalf of you, put your label, put your name and ship, right? And ship it to the customer, right? So that's called outsourcing the production or subcontracting, right? So what this tablet company can do is, since they have 7,000 hours of program and 4,000 hours of test remaining, they can accept subcontract orders, right, for a company who doesn't have enough capacity, right? So a tablet company can put an advertisement or something and say, we have 7,000 hours of program, 4,000 hours of test extra capacity. So if you don't have enough capacity in your factory, we can do the production on behalf of you. You can outsource your production to us. So basically, you're renting out your capacity. You're renting it out to another company. You're hiring it out or renting it out to another company. So it's like you have your house, you rent it out to someone else. So similarly, you have your capacity, you rent it out to another company. Clear? So that's what you can do with Slack. So there could be an MCQ question as to what you do with Slack. So what do you do with Slack? You rent it out to another company by accepting uh, outsourced orders, right? Okay, so let me put the note. Okay. Clear? So that's what you do with Slack. Okay. So take down this note also. The second note that I just gave. Right. Clear guys on how to calculate. So first, what is slack? How to calculate slack? When does slack occur? What to do with slack? Are you all clear on that part? Any questions? All okay? No questions, no? Right. Now, uh, go to the tute and go to page number 12, question number 3. The same question that we did last week. We found the optimum point, solved the graph, and uh, got the optimum production plan. So now what I want you all to do for this question, right? For this question, how many resources are there? How many resources are there? Material A, material B, and labor, right? Those are the three resources that are there. So just like we did for build, program, and test, I want you all to calculate just like in the same format. I want you all to calculate the slack for material A, material B, and labor. Do it. Calculate the slack for material A, material B, and labor using the same format that we used for build, program, and test calculation. Do it, guys. Calculate the slack. Okay, done. Let's discuss. So three resources: material A, B, and labor. Okay, there is this question. I'll answer it if in case a few of the others also have this question. In the last question, uh, uh, this question is not too clear. Can you send it to me again clearly? Then I don't understand it exactly. Right. So until that, let's go through it. So you have material A, material B, and labor. Right. So page 12, question 3. Okay. So here also we have product X and product Y. Oops. Sorry. Product X. Yeah. Then so for product X, let's take amount per unit. Amount per unit. So to produce 1 unit of product X, how many kilos of product A or material A do we need, guys? Yeah. How many kilos of material A do we need? We can divide and take, right? We can divide and take. How do we divide and take? To produce 1 unit of product X, material A cost is $40. See, this is dollars too. So to make 1 unit of product X, the cost is $40, right? And each kilo of material A will cost $8. 1 kilo of material A is $8, and the material A cost for 1 unit of product X is 40. So then if 1 kilo is $8, how many kilos have we used for the cost to be 40? We have used 5 kilos. 1 kilo එකක් $8යි නම් cost එක 40 වෙන්න කිලෝ කීයක් පාවිච්චි කළා. Right? I'll put a working column here. Yeah. So that will be $40 per unit divided by $8 per kilo. Okay, that will be 5 kilos. 40 divided by 8 will be 5 kilos, right? Sorry. Then multiplied by number of X units produced. Now guys, when you take X units produced, right? Now, see in this question, right? I think the last question is also related to that. Don't get yourself confused. Huh? Now, in the previous question, I think the question was asked that was asked earlier. I think it's related to this. Now, when you're taking the number of X units and Y units, you should always refer to the optimum production plan. Okay, optimum production plan. Now, certain students might take X as 85,000 units and Y as 66,000 units. Guys, 85,000 and 66,000 is not how many units we are going to make. No, yeah, I made it clear in the last class also. 85,000 and 66,000 means that is the maximum demand, right? What is maximum demand? That means that is the maximum amount we can sell. Yeah, that is the maximum number of units of X and Y we can sell. That doesn't mean we are going to make 85,000 units or we are going to make 66,000 units. Okay, that only means that the maximum number of X units I can sell is 85,000 and the maximum number of Y units I can sell is 66,000. Okay. Now in this question, if you look at the graph, the optimum production point fell on point D, no, right? Now at point D, the two constraints that are intersecting are build resource and demand for Y, right? Now demand for Y. Now from that, we have the constraint, right? If I just take a minute and go to this so that everyone is very clear and you don't make any mistakes, right? Now we have the constraints, no? Remember the constraint that we made in step number 3? Yeah, for all the resource constraint, we made constraint equation, build, program, test. To demand constraint also, we made constraints X 85,000, Y 66,000, right? Remember? Yeah. So the two constraints that are intersecting at the optimum point is demand for X, sorry, demand for Y 66,000 and the build time. So if you write now, how when you solve the optimum point, how you solve is by writing the two constraints that are intersecting at the optimum point. So one constraint that is intersecting at the optimum point is build. 24x plus 20y equals 1.8 million. The second one is demand for y equals 66,000. Now, y is equal to 66,000, no guys. So here, this y equals 66,000 doesn't mean the fact that this 66,000, right? This 66,000 and 85,000 is the maximum demand. Now, why we have taken here y equals 66,000 is when we look at the optimum production point, the optimum production point falls on the maximum demand for y, right? So basically guys, you have to take the two lines that are falling, the two constraints that are falling on the optimum point. So you have build time, you have demand for y, not demand for x, no, demand for y. So you can only take demand for y. Okay, so you have taken y equals 66,000. Now then since we already know the value of y equals 66,000, right? Y is equal to 66,000, that we already know. So basically optimum production plan means how many units of X and Y are we going to produce, right? How many units of X and Y are we going to produce? So since the optimum production point fell on build constraint and demand for Y, we already know demand for Y, the constraint is Y equals 66,000, right? We found that out, no? We found that out, right? Demand for Y equals 66,000. That's a constraint, right? So that means at this point, we already know the value of Y. We don't know the value of X, no, we only know the value of Y. Y equals 66,000. So if Y is equal to 66,000, we take that 66,000 and substitute into this Y right here, right? Because we know the value of Y, but we don't know the value of X, because understand this Y equals 66,000 came because in the graph point D, right? Point D is falling on build time and the demand for Y. That's why we took that. It doesn't mean I took it from the question and Y is equal to 66,000, X is equal to 85,000. That is completely wrong, right? That cannot happen, right? So therefore, when you take, right, when you take Y is equal to 66,000, how did we take it? Why did we take it? Because in the graph, the optimum production point fell on build time and maximum demand for Y. Okay, build time and maximum demand for Y. Okay, so therefore we took Y equals 66,000, right? So therefore since we know Y equals 66,000, we take that Y equals 66,000 and we substitute into this, right? And when we substitute into this, we get the value of X, right? Hope that is clear. Okay, don't make that mistake. And when you do the slack calculation, guys, you have to take the number of X units and Y units from the optimum production plan, not from what is given in this question. Given in the question is the maximum demand, right? Maximum demand. Maximum demand doesn't mean we are going to produce that number of units. You have to always take the optimum production plan, right? I have repeated this many times. The number given in the question is always the maximum demand, right? That's the maximum number of units you can sell. Why is it given to you? That is for you to draw the graph, the maximum demand for X and maximum demand for Y, the demand constraint. That's why it's given to you, right? And if, like in this question, if the optimum point falls on a particular demand constraint, like in this question, it's on maximum demand for Y, then you have to take that constraint like we have taken here. Build is 24x plus 20y equals 1.8 million. Demand for Y is Y equals 66,000. So since we know already Y equals 66,000, you substitute and get the answer. Okay. So remember guys, when you do the slack, always take from the optimum plan, not from the question. Okay. If you take from the question, you will go wrong. You have to always take from the optimum plan. Right. So we'll take quickly all material A, B, and C, labor at the same time. Now let's take material B. Material B, to make 1 unit of product X, the material B cost is $20, and material B cost per kilo is also 20. So how many kilos of material B have I used to make 1 unit of product X? 1 kilo. I don't have to explain it so elaborately. No? right? 1 kilo. Okay. Then labor. To make 1 unit of X, the labor cost is $75 and the labor rate is 25. So for 1 hour, if I have to pay 25, for the cost to be $75, I have used 3 hours. 75 per unit divided by 25 per hour. So for 1 unit of X, I have used 3 hours. Okay. Multiplied by number of X units produced, right? So here, like I said, let me put it in writing also. Optimum production plan. Optimum production plan. Right? Let me put it here also. Right. So how many units of X are we going to produce? Last week we solved the question and got the optimum point. No. What is the optimum point? 1700 units of X. This we did last week. Huh? Okay. 1700 units. Now this will tell us the usage for product X. So material A, 5 kilos per unit into 1700 units, 8500 kilos. Material B, 1 kilo per unit into 1700 units, 1700 kilos. Labor, 3 hours per unit into 1700 units, 5100 hours. Clear? Right. So this is the usage for X. Then let's take the usage for Y. Right. So to make 1 unit of Y, how many kilos of material A? 16 divided by 8, 2 kilos. Right. I'm going a bit fast, guys. Now see these things. You all should be able to understand. 8 per kilo. 2 kilos. B, 60 divided by 20, 3 kilos. Labor, 100 divided by 25, 4 hours. Multiplied by number of Y units. Check the optimum production plan we did last week. 825 units. Right? So 2 into 825 is 1650 kilos for material A. 3 into 825, 2475. Material B. 4 into 825, 3,300 hours for labor. So total resource usage. Total resource usage x plus y, material A 8,500 plus 1,650, 10,150 kilos. Material B 1,700 plus 2,475, 4,175. Labor 5,100, 5,100 plus 3,300, 8,400 hours. So total resource available, how much? Material A available 10,150 kilos. So I have 10,150 kilos and I have used 10,150 kilos. What's the slack? 0, right? Material B, I have 5,500 kilos and I am using only 4,175 kilos. So the slack is 1,325 kilos. Labor, I have 8,400 hours and I'm using 8,400 hours. Okay, 0 slack. Okay, so that is your slack. So material A, no slack. Material B, 1,325 kilos of slack. Labor, no slack. So this indicates the fact that, guys, at the optimum production plan, what are the two resources that are intersecting? You can see we found this out last week, material A and labor. That's why material A and labor slack is 0. Material B, you have a slack. Clear? Any questions? Clear on this? Okay. Right. So that is slack, guys. Clear on slack? So we did 2 questions on that. Next, let's go through the next and the final area, shadow pricing. Shadow pricing. So what do you mean by shadow pricing? Yeah. What do you mean by shadow pricing? So first thing is, guys, shadow price is not a real price. Okay. Shadow price is not a real price. Yeah. It is used only for analysis purposes. That's all. Right. So shadow price is not a real price. it is only used for analysis and decision making purposes, right? Decision making purposes. So first of all, you need to understand that shadow price is not a real price. It is only used for analysis and decision making purposes. So now that you know that, what is shadow price? What do you mean by shadow price? Yeah. So shadow price is, guys, basically, right? Shadow price is basically how much more, right? How much more am I willing to pay, right? How much extra, okay? How much extra am I willing to pay to buy one more unit of a resource? Okay, understand it carefully. How much extra am I willing to pay to buy one more unit of a resource? Clear? How much extra am I willing to pay to buy one more unit of a resource? Clear? So that's the definition. Shadow price is how much extra the company is willing to pay to obtain one more unit of a resource. One more unit of a resource, right? So when you say extra, what do you mean by extra, guys? We are saying how much extra, no? Right? How much extra? So what do you mean by extra? Extra means over and above the normal price. Over and above the normal price, how much are you willing to pay? Over and above the normal price, how much extra are you willing to pay? Let me take an example, right? Current price of material, right? Current price of raw material is, let's say, $10 per kilo, right? So if the price of raw material is $10 per kilo, right? Shadow price means how much more, right? How much extra are you willing to pay, right? How much extra are you willing to pay? That is over and above $10, because $10 is the normal price, no? To obtain one more kilo of raw material, how much extra, more than $10 are you willing to pay? So let's say, for example, guys, your shadow price, right? Your shadow price is, let's say, $2, right? Let's say shadow price is $2. I'm just taking a hypothetical number, right? So if your shadow price is $2, guys, that means, right? That means you're willing to pay $2 extra. So when you say you're willing to pay $2 extra, it means that now earlier the current price is $10, but you're willing to pay $12 to buy one more kilo. Clear? Shadow price $2 means you're willing to pay a total of $12 to buy one more kilo, because the current price is $10. Shadow price is $2. Shadow price means over and above the normal price. Normal price is 10. Over and above the normal price, how much extra are you willing to pay to buy one more unit of a resource? Clear? So if your normal price is 10, if shadow price is 2, that means you're willing to pay $2 extra above the normal price to buy the kilo. So that means in total, you're willing to pay now $12 to buy 1 kilo. Clear? Yes. So there is a question, is it the incremental amount? Not, is it the incremental amount? Yes, it is the incremental amount. So shadow price is only the extra part, extra part. So now the total amount, right? Total price you are willing to pay. total price you are willing to pay is 12, but shadow price is 2. Shadow price is only the extra amount you are willing to pay. Extra amount you are willing to pay. Clear? Any questions? Right. So let me expand the note. You can take down this note when I'm writing. Take this note down. Right. Next. Now, the next thing about shadow pricing is, guys, see, this is, so shadow pricing is, guys, how much you're willing to pay extra to obtain one more unit of a resource, no, guys? Yeah. So uh, basically, guys, uh, this will only apply, right? Shadow price will only apply to a scarce resource, right? Scarce resource. Because, guys, if resources are readily, freely available, you don't have to pay extra. No, you want to pay extra to buy one unit of a resource only because the resource is a scarce resource. That means you don't have enough of this resource, isn't it? If you have enough of this resource, you will not be willing to pay extra. No, think about it. Why are you willing to pay extra? Because this is a scarce resource, right? Scarce resource. So I'll add the word here, scarce resource. One more unit of a scarce resource, right? Scarce resource. Clear? So what you need to understand is, guys, since it's a scarce resource, right? Since it's a scarce resource, that means you don't have enough of this resource available, right? You don't have enough of this resource available. So basically, guys, what you need to understand is, now if you take a particular, resource, right? If you take a particular resource, right? Which resources are scarce resources, guys? Uh, let's go back to um, the graph, right? Now, in this slack calculation, we said if a particular resource falls on the optimum production point, right? If a particular resource falls on the optimum production point, that resource is going to be fully utilized. Yes or no? Isn't it? So in the slack calculation also, that is what we saw. The resource that fell on the optimum production point was fully utilized, and we didn't have any resources remaining. And the resources that didn't fall on the optimum production point was not fully utilized, and there was a extra unutilized or slack value left. Clear? So basically, guys, what you need to understand is, guys, a scarce resource is a resource that has no slack, right? So that's what you need to understand. So here I will say a scarce resource, a scarce resource is a resource that does not have a slack. It means that the resource is fully utilized and no more is left. Therefore, the company is willing to pay extra to obtain more units of these scarce resources. Clear? Right? So to the Slack also, guys, I'll add a note here. a resource is fully utilized and does not have a slack, it is called a scarce resource. It is called a scarce resource. Clear, guys? Any questions? Any questions so far? Nothing? Right. Okay. So a scarce resource is a resource that does not have a slack, right? So that means, guys, only scarce resources will have a shadow price. Only scarce resources or resources that does not have a slack will have shadow price. So only if a resource does not have a slack, it will have a shadow price. Why is that, guys? Because you are willing to pay extra, right? Because it is a scarce resource and you don't have enough. But if it's a resource that has a slack, right? If it's a resource that has a slack, before you pay anything extra, before you ask for more, first you have to use what you have, no, isn't it? So therefore, a shadow price will only be applicable if the resource is not a scarce resource. Sorry, only if the resource is a scarce resource. That means you don't have enough. So for example, if you take the build resource here, it is fully utilized, fully over. You don't have anything left. So it's a scarce resource. So you need more. So for to get more, you will be willing to pay extra. So that means, guys, in the graph, right? In the graph, which resources will have a shadow price and which resources will not have a shadow price? If a resource falls on the optimum production point, it will not have a slack. Therefore, it is a scarce resource and therefore it has a shadow price. Clear? If a resource falls on the optimum production point, it means that it will not have a slack. That's what we learned during the slack note. It will not have a slack. It is a fully utilized resource. It's a scarce resource. Therefore, it will have a shadow price. If a resource does not fall on the optimum production point, it means that the resource is not fully utilized. It will have a slack and therefore will not have a shadow price. If you have a slack, you can't have a shadow price because having a slack means it's not a scarce resource. Clear? So in short, if a resource falls on the optimum production point, it will have a shadow price. If a resource does not fall on the optimum production point, it will not have a shadow price. Clear? That's the simple logic. Clear? Any questions, guys? So this is the theory about shadow pricing. Now let's do a calculation, right? Let's calculate the shadow price for the tablet company example, right? So before that, guys, before that, what is the shadow price? In the sense, what does how is the shadow price value arrived at? Now, you know, shadow price is how much extra you are willing to pay, and how much of extra means what? Yeah, how much of extra? Now, we said shadow price is how much of extra are we willing to pay to buy one more unit of a resource, right? How much are we willing to pay to buy one more unit of a resource? So how much is that amount? How much you are willing to pay to buy one more unit of a resource? The maximum amount you are willing to pay to buy one unit of a resource is the maximum contribution that one extra unit of the resource will give you. Clear? How much are you willing to pay to buy one extra unit of a resource? The maximum amount you are willing to pay to buy that one unit of a resource is the maximum contribution that one unit of the resource will give you. By having that one extra unit, yeah, by having that one extra unit of the resource, how much of additional contribution can you earn? Clear? By having that one extra unit of a resource, how much of additional contribution can you earn? Right? Right? How much of additional contribution can you earn? So the maximum amount you are willing to pay is that additional contribution that one extra unit of the resource will give you. For example, guys, let's say if I have 100 kilos, or let's say if I have 1000 kilos of raw material, right? I can earn a total contribution, right? The total contribution of, let's say, $10,000, right? But if I have 1001 kilos, one extra unit, one extra kilo, I can earn a total contribution of $10,015. $10,015. So, right? So, by having that one extra kilo, right? By having that one extra kilo, how much of extra contribution did I earn? $15. Clear? By having that one extra kilo, I earned an extra contribution of $15. So this is the maximum amount I am willing to pay, and this is what I call as the shadow price. This is what I call as the shadow price, right? How much extra am I willing to pay? The amount I'm willing to pay extra is the additional contribution I earn by having one extra kilo or one extra unit of a resource. Clear? Any questions? Are you all fine? Right. Okay, right. Okay, right. So that's an example. So now let's get into the example of tablet company. So for the tablet company example, let's calculate the shadow price. Give me 1 minute, guys. Right. So in the tablet company example, guys, how many resources are there? Three resources, right? So I told you that only for scarce resources that we can calculate shadow price, or in other words, only if a resource falls on the optimum production point, we can calculate a shadow price. If a resource does not fall on the optimum production point, we cannot calculate a shadow price. So in the tablet company example, guys, which resources does have a shadow price? Which resources will have a shadow price? Tell me. In the uh, tablet company example, which resource or resources will have shadow price? Yeah, only the resources that falls on the optimum production point. So in the tablet company example, there is only one resource that falls on the optimum production point, that is build. So build will have a shadow price because it falls on the optimum point and is a scarce resource. Program and test will not have a shadow price because it does not fall on the optimum point and is not a scarce and are not scarce resources. Clear? So I will say here, in this question, only build resource will have a shadow price since it is the only resource that falls on the optimum production point and is a scarce resource. Clear? Program and test will not have shadow price since they do not fall on the optimum production point and are not scarce resources. Okay, right. So let's calculate the shadow price of build. Let's calculate the shadow price of build. Right. Now, guys, how do we calculate the shadow price of a resource? To calculate the shadow price of a resource, basically, guys, um, shadow price is how much extra you are willing to pay to buy one more unit of a resource. No? And how much is that amount? That amount is the additional contribution that the one extra unit of a resource will give you. Yeah. So we need to find out, guys, basically, if I have one extra unit of build, right? If I have one extra unit of build, or if build is measured in hours, no? If I have one extra hour of build, right? If I have one extra hour of build, how much of additional contribution can I earn? Clear? If I have one extra hour of build, how much of additional contribution can I earn? So that is basically your shadow price. Clear? So I will say we need to calculate the additional contribution earned if we have one extra hour of build, right? 1 extra hour of build. To do that, we need to increase the build resource by 1 hour at the optimum production point, right? At the optimum production point. So basically, guys, right? So we need to find out what is the additional contribution we will earn if we have 1 extra unit of build or 1 extra hour of build. So to do that, how we are going to do that is we are going to increase the build resource by 1 hour, right? Increase the build resource by 1 hour at the optimum production point. So let me show you all how to do it. So remember how we solve the question. Remember, at the optimum production point, we put the two constraint equations. Remember, build was 24 plus 20x equals 1 million, 1.8 million, right? And demand for y was y equals 66,000. So basically, we wrote the contribution, wrote the two equations and solved it. No. So guys, currently, how much of build minutes do I have with me, guys? How much of build minutes? Sorry, no, build is in minutes, no, not hours, right? 1 minute, not hours, 1 minute, right? Minute could be converted into hours later, but since we are measuring in minutes, uh, let's take it like that. So currently, guys, how many minutes of build do we have? Yeah, currently, how many minutes of build do we have? We have 1.8 million minutes of build, right? So we need to understand, okay, with 1.8 million minutes of build, guys, how much of contribution did I earn? I earned $3,240,000 of contribution. Yes or no? Yes, right? With 1.8 million minutes of build, I got an optimum production plan of 20,000 units of X and 66,000 units of Y. That's clear, no? And when I had that, I got 600,000 contribution from X, 2.64 million contribution from Y. So the total contribution I earned with 1.8 million minutes of build is 3.24 million. Clear? Yeah. So then we need to ask, okay, with 1.8 million minutes of build, if we got a contribution of 3,240,000, if I have 1 extra minute of build, that means 1,800,001 minutes of build, how much of contribution can I earn? Clear? So that's what we are going to calculate. So currently we have 1,800,000 minutes of build, and the contribution earned with this amount of build resource is $3,240,000. Okay, so you have to refer this uh, calculation. Nah? It's coming from this calculation, right? With 1.8 million minutes, we got $3,240,000 of contribution. Clear? Right? It's all linked to this, huh? Right. Now, at optimum production point, guys, the two equations that we got were these two. No? We got these two. We got 20x plus 24x plus 20y equals 1.8 million and y equals 66,000. So these were the two equations, right? So now what we need to do, is, guys, we said with 1.8 million minutes with these two constraints, right? With build resource being at 1.8 million minutes, we got a total contribution of 3,240,000. Now let's increase the build resource by 1 minute. So instead of 1,800,000, now I'm going to increase it by 1 unit to 1,800,001. And then we will solve the optimum production point. Clear? Right? So I will say increase the build resource by 1 minute at the optimum production point. Clear? So now my two equations are 24x plus 20y equals 1,800,001 and the demand for y is 66,000. So if you're calculating the shadow price for build, you should only increase the build resource. Clear? You should always increase only one. Now if you're calculating for build, you only increase the build resource by one. Other you don't increase, right? Other you have to keep the same. Clear? Similarly, if you go to this now, that in this particular tablet company question, only build is the resource constraint. No? Other one is a demand constraint. But if you go to that other question that we did, this particular question, right? There are three resources: material, A, B, and labor. So if you're calculating now at the optimum production point, the two resources that are meeting is material A and labor. These are the two constraints that are meeting. So if you're calculating the shadow price for material A, you only increase material A by 1 unit. Labor you keep the same. Clear? Right? If you're calculating the shadow price for labor, you increase the labor resource by 1 unit, you keep material A the same. Clear? You can't increase both at the same in the same calculation. Clear? If you're calculating for material A, increase only material A. If you're calculating for labor, increase only labor. Clear? Any questions on that? Fine? Right. Okay. So we increase. Now what I want you all to do is substitute y equals 66,000 into this equation and find out the optimum production plan. Y is anyway 66,000, right? I want you all to substitute this y equals 66,000 into this equation and find out how much is x now. Calculate and tell me quickly how much is x. Tell me how much is x. It's okay to have decimals, huh? It's okay to have decimals. Tell me to 2 decimal places. Tell me to 2 decimal places. Tell me to 2 decimal places. So X is 20,000.04 units, right? 20,000.04 units. And Y will still be 66,000 units. That will not change. Clear? Right. So now calculate the total contribution at this with 1,800,001 minutes of build resource. Yeah. So this is what we have to do. Let's calculate. So product X contribution per unit is 30, Y is 40. Number of units now, X will change to 20,000.04, right? So the contribution will be $30 per unit into 20,000.04, right? Y will be $40 per unit into 66,000 units. 2,600,040, right? So total contribution with 1,800,001 minutes of build. So if I have with now this total contribution, how much is it? 600,000 and 1.2 plus 2,640,000. It's 3,240,000 and 1.2. Clear? So this is the contribution that I got with 1,800,000 and 1 minutes of build. Clear? Clear? Right. Whereas when I had 1.8 million minutes of build, how much of contribution did I earn? The earlier calculation that we did. Yeah, here with 1.8 million minutes of build, with 1.8 million minutes of build, we had a contribution of 3,200 and 3,240,000, isn't it? 3,240,000, right? So with 1.8 million minutes, I had a contribution of 3,240,000. When I increased it to by 1 minute, my contribution increased to 3,240,000 and $1.2. So therefore, how much of contribution did this additional 1 minute give me? A contribution of $1.2, right? $1.2 for every minute, right? So basically, guys, when I increase the resource by 1 minute, my contribution increased by $1.2. So basically, therefore, uh, the contribution earned by the additional contribution earned by 1 extra minute of build resource, or the shadow price of build resource shadow price of build resource is $1.2, right? $1.2 per minute. $1.2 per minute. So this is the shadow price. Shadow price of build is $1.2. So for every extra minute that I get, that I want to get from of build, I am willing to pay $1.2 extra, right? So here I will say this is the extra amount over and above the current rate of build that tablet company is willing to pay to obtain one extra minute of build. Clear, guys? Any questions? So basically, what is the current rate of build? The current rate of build is $10 per hour, right? $10 per hour. Let's do the calculation as well. Current rate of build per hour is how much? $10. Right? Right? Current rate of build is $10 per hour. Therefore, so what is the shadow price, guys? Shadow price per hour is how much? For every minute, how much extra am I willing to pay? For every minute, I am willing to pay $1.2 extra, right? I am willing to pay $1.2 extra per minute. And for 1 hour means 60 minutes, no? It will look like a big amount, but that's fine, right? That's what it is. That's what it is, okay? $1.2 per minute is the shadow price. So for 1 minute, if it's $1.2, for 1 hour, how much is it? 1.2 per minute into 60 minutes, $72, right? Shadow price is $72. Current rate is 82. So total rate that tablet company is willing to pay per hour of build. Total amount that tablet company is willing to pay per hour of build is 10 is the current rate, 72 is the shadow price per hour, total 82. So total, now you are willing to pay a maximum of maximum. Make it very clear, total maximum. right? Shadow price is always the maximum, okay? Maximum. So the maximum rate you are willing to pay is $82 per hour, right? Because $82 per hour is the maximum contribution that 1 hour of build will give you, right? 1 minute of build gives you $1.2 of contribution, right? Extra contribution. So if 1 minute gives you 1.2, 1 hour will give you how much? 1.2 into 60, right? 72, right? So you're willing to pay $72 extra maximum amount, right? So current rate of 10 plus extra rate of 72, the maximum amount that you're willing to pay is 82. Now this doesn't mean that you will pay 82, but you need to understand where to draw the line, where to stop. So the maximum you will pay is $82, right? So let me explain that as well here. Is willing to pay for 1 hour of 1 extra hour of build is $82. This does not mean that they will actually pay $82. This is the maximum they should pay. This value is for analysis and decision making purposes only. Now it doesn't, guys, this rate call 82 doesn't exist, no, or rate call 72 doesn't exist, right? It's just for analytics and decision making purposes only. Clear? Right. So I all fine with how we calculated shadow price here. Basically, you take the resource and at the optimum point, you increase it by 1 and then calculate how much of extra contribution you will earn. Clear, guys? Any questions? Are you all fine with this? All okay? No questions? Are you all fine then? I'm assuming you all are fine then. Okay, let's take a break then. Now the time is 4:40. Come back by 5:05 and let's continue, right? We have to do a few more questions. Okay, so there is one question. Wait a minute. Why do we add 10 and 72? Okay, so probably you were not listening to me properly earlier, right? Now I told you very clearly, shadow price is the extra amount you're paying. Now, දෙතුන් පාරක්ම මං කිව්වා අහන් ඉන්න හරියට. Okay? Shadow price is the extra amount that you are paying. Okay? Extra amount means I very clearly mentioned here over and above the normal price. Over and above the normal price, right? So දැනට ගෙවන ගානට වැඩිය කොච්චර ගෙවනවද? ගෙවන්න ඕනේද? ගෙවන්න කැමතිද? Right? So now the current rate of build is kiyada 10 no, right? Understand this very clearly, yeah? Ayandepa. Current rate is 10. So shadow price means above this 10, more than 10, more than the current rate of 10, how much of extra? ඒ 10ට වැඩිය තව කොච්චර ගෙවන්න කැමතිද? So this $1.2 per minute or this $72 per hour is how much you are willing to pay more than the normal rate. Normal rate එක 10 නේ, normal rate is 10. So normal rate is 10, that is there above the normal rate. More than the normal rate, how much of extra are you willing to pay? extra means above the normal rate, right? So above the normal rate, $72 you're willing to pay extra, right? $72 you're willing to pay extra, right? Currently you're paying 10, you're willing to pay another extra 72, right? Another extra, right? So another extra 72 more than the normal rate of 10 is 82, ne? Right? More than the normal rate extra is 82. Normal rate is 10, right? Normal rate is 10. Extra amount you're willing to pay is 72. So total, right? Again, extra amount. ඔළුවට දාගන්න හොඳට අහන් ඉන්න. Right? Extra amount means more than the normal rate. තව කොච්චර වැඩිපුර ගෙවන්න කැමතිද? More than the normal rate, how much more are you willing to pay? So no, $10 you will anyway have to pay, right? But shadow price means above the normal rate, how much of extra are you willing to pay? So the 72 is how much extra, right? More than the $10. Above the $10, you're willing to pay another extra 70. So that means total you're willing to pay is normal current rate, the normal base rate $10 plus extra 72. So total you're willing to pay 82. Clear? Right? So please listen and focus when I am explaining, because I explained this amount 2-3 times here. Clear? I explained it here, I explained it here, right? So you should listen carefully when I'm explaining, right? Hope it's clear now, right? It is always the extra amount above the normal rate. Above the normal rate, how much extra, right? So normal rate is 10, extra rate is 72. So total rate you're willing to pay is 82. Clear? Any more questions? Right, so then let's take the break. Come back by 5:10. Okay, come back by 5:10. Right, let's continue, guys. So we all are clear on how to do the shadow pricing. No? So now what I want you all to do is go to that other question, page 12, question number 3. Right, page 12, question number 3. So for this question, I want you all to let me share the screen. For this question, I want you all to calculate the shadow price. Now, shadow price is there for the two resources that are intersecting at the optimum production point. So what are the two resources that are intersecting? Even if you look at the slack working, you can find out which two resources has zero slack: material A and labor. So material A and labor are the two resources that are intersecting at the optimum production point. So for those two, you should be able to calculate the shadow price. Shadow price of material A, shadow price of labor. I want you all to do that. Calculate the shadow price of material A and shadow price of labor. Clear, guys? Right. Start doing it. Calculate the shadow price of material A and labor. Use the same working, do the same working that you all did for the build resource. At the optimum production point, increase the particular resource by 1 unit, right? Calculate for material A and labor. Shadow price. calculate for both material A and labor, shadow price for both material A and labor. let's go through it. So the shadow prices are there for material A and labor. Right. So first, let's calculate for material A. So if it's material A, let's take at the optimum point. At the optimum production point, what are the two constraints? We did it last week, no? So let's take, these are the two. These are the two constraints intersecting at the optimum production point. So now we are trying to calculate the shadow price of material A, right? So to calculate the shadow price of material A, we will increase the material A resource at the optimum point by 1, right? Keep the labor you have to keep the same. Huh? You should only increase the shadow price of the resource that you should only increase the amount of the resource for the material or the resource that you're trying to calculate the shadow price only. If it's material A that you're calculating, you should only increase material A resource. You have to keep labor the same. If it's labor that you're calculating, you should increase the labor resource and keep material A the same. Clear? Right? Okay, so let's calculate. Now, so for that, I'll put a sentence. Currently, 10,150 kilos of material A is available, which generated a total contribution of when I had 10,150 kilos of material, guys, how much of contribution did I generate? See, we did the calculation here. Total contribution generated was $135,100. Yeah, with 10,150 kilos of material A, my optimum plan was 1,700 units of X, 825 units of Y, and the total contribution was 135,100. Yeah. Contribution of 135,100. Okay. Now I increased it by 1. Now you can use the linear simultaneous equation method and find out the optimum production plan. Remember last week I taught you all the calculator method of solving the linear simultaneous equation. So tell me, so you all have to use the calculator method that I taught you all last week to solve these two simultaneous equations. Okay. So what is the how many units of X, guys, and how many units of Y? What is the optimum production plan? Tell me. Tell me, guys, quickly. With 10,151 kilos of material A, What is the optimum production plan? How many units of X and Y? Tell me guys quickly. Send it to me on the chat. Uh, 1700.29 units of X and 824.79 units of Y. Clear? So like I explained very clearly, guys, you have to only increase that particular material. I told you all very clearly, yeah. You have to increase. If it's A, you only increase material A by 1. If it's labor, you only increase labor by 1. Other one you have to keep the same. Clear? Right. So now let's calculate the total contribution with 10,151 kilos of material A. Right. Okay, so contribution per unit of X is 62, Y is 36. We calculated that last week. So now number of units of X will now be 1700.29. Y will be 824.79. Right? So contribution will be X 62 per unit into 1700.29 and Y 36 per unit into 824.79. So the total contribution will be the addition of these two, 135,110. So total contribution with 10,151 kilos of material A. When I have 10,151 kilos of material A, my total contribution is 135,110. Then if I with 10,150 kilos, when I had 10,150 kilos, my contribution was $135,100, right? So when I increased my resource by 1 kilo of material A, my total contribution increased by how much? $10. So the shadow price is $10 per kilo. Shadow price of material A, $10 per kilo. Clear guys? Any questions? Clear? Any questions? Right. So similarly, same thing. Let's calculate labor. Labor shadow price. So currently, guys, we have 8,400 hours of labor. And with 8,400 hours of labor, we were able to generate a contribution. See, labor, we had 8,400 hours. With 8,400 hours, we generated a contribution of 135,100. So always you compare against the original contribution. Clear? Of labor available which generated a total contribution of $135,100. Increase labor by 1 hour at the optimum production point. Calculate the shadow price. Okay, so now this is the optimum point. Now you increase labor by 1 hour. Keep material A the same, 10,150, and increase labor to 8,401. So the optimum production plan, with 8,401 hours of labor is how much, guys? What is the optimum production plan now with 8,401 hours? Tell me. X is 1,699.86, is it? And Y is 825.36 units. Okay. So this is the optimum production plan now. So now we need to calculate the contribution with 8,401 hours of labor. Right. So now 1,699.86 units and 825.36 units. So contribution from X 62 into number of units, Y 36 into number of units. So total contribution now 135,104. So the total contribution with 8,401 hours of labor is 134,104. Total contribution, the original contribution with 8,400 hours of labor was 135,100. Clear? So now the shadow price will be $4 per hour. $4 per hour. Clear, guys? Shadow price, yeah, shadow price of labor and material A. Clear? Any questions? So are you all clear on how to calculate the shadow price now? Right, good. So basically now we are done with shadow price, right? Okay. Right, now come to page number 11. Right, page number 11, do question number 1. Do question number 1. Right. The shadow price of skilled labor for CBV Limited currently is $8 per hour. What does this mean? A. Cost of obtaining additional skilled labor is $8 per hour. There is a hidden cost of $8 uh, for each hour of skilled labor that is actively worked. Contribution will be increased by $8 per hour for extra per hour of each extra hour of skilled labor that can be obtained. Total cost will be reduced by $8 for each additional hour of skilled labor that can be obtained. What is the answer? Answer C. Right. So we know shadow price is how much extra are you willing to pay. How much is that extra? The contribution that that one extra unit will generate. Clear? Answer C. Now do question number 2. Do question number 2. I'll give you all about 3 minutes. Quickly do it. Question number 2. Sorry guys, some network issue. Right. So Q1 and Q2, selling price, direct material, direct labor, variable overheads, and the contribution. The maximum demand for these products is Q1 500 units per week. That's the maximum demand, demand constraint. Q2 unlimited number of units per week. So that means demand for Q2 is not limited. We can sell any amount we want. If material were limited to 2000 kilos per week, the shadow price of this material would be, right. Now guys, tell me how many resources are limited? How many resources are limited here? There is only one resource that is limited, right? Yes or no? Yes. So if there is only one resource that is limited, should we use linear programming? Should we use linear programming? No. Linear programming is for multiple resource constraint. If there is only one resource constraint, what is the method that we learned last week or the week before? If there is only one resource constraint, we have to use limiting factor analysis. Remember from your BA2, we did a recap also before we did linear programming. You have to use limiting factor analysis, right? Since there is only one resource constraint, limiting factor analysis should be used. Clear guys? Is everyone okay with that? We should not use linear programming because there is only one resource constraint, and we learned that if there is only one resource constraint, you have to use the limiting factor analysis method, right? Linear programming is used only if there are multiple limited resources or constraints. Clear? So since there is only one resource limited, one resource constraint, we should use limiting factor analysis. So, but in limiting factor analysis, we didn't learn something called shadow price, right? We didn't learn something called shadow price. No, we learned only something called contribution per limiting factor. Shadow price, we only learned in linear programming. So why are they asking the shadow price in a limiting factor analysis question, guys? Yeah, so shadow price is just the name, right? Understand what shadow price means. Yeah, you need to understand what shadow price. So sorry. So basically, guys, what does shadow price mean? Shadow price means how much extra you're willing to pay to buy one more unit of a resource. How much is that amount? That amount is the extra contribution or the contribution that one extra unit of the resource generates. Yes or no? Yes. Shadow price means how much contribution that one extra unit of the resource generates. Yes or no? Yes. Right. So let me put that statement also. Shadow price is how much contribution one extra unit of a resource will generate. Clear? That is what shadow price means, right? So now let's understand, guys. Now this is a limiting factor analysis question. So since it is a limiting factor analysis question, right? Now they have told us we only have 2000 kilos of raw material per week, right? Right? And Q1, the demand is 500 units. Q2, the demand is unlimited, right? So let's understand for Q1 and Q2, what is the contribution per limiting factor? Because we need to understand how much of Q1 and how much of Q2 we should produce in order to understand the shadow price. or the contribution from one extra kilo of material, right? So we have product Q1 and Q2. Contribution per unit. Contribution per unit of Q1 is how much, guys? 8. Q2 is 8.5. Right? You have to divide this. Right? You have to divide this. Divided by amount of limiting factor used per unit. Kilos per unit. To produce 1 unit of Q1, how many kilos of material should we use? Yeah, material cost of Q1 is $6 and each kilo will cost you $2, right? So that means we have used 3 kilos. $6 divided by $2 per kilo. Then Q2, to make 1 unit of Q2, I need to spend $5, right? And each kilo is $2. So how many kilos have we used? 2.5 kilos. How do we find that? $5 divided by $2 per kilo. Right? So this will tell us the contribution per limiting factor. Limiting factor is material, they have given as material. So let's calculate the contribution per limiting factor of Q1. To 3 kilos of the limiting factor gave $8. So 1 kilo should give 2.67. So the contribution per limiting factor is $2.67 per kilo. And here Q2, 2.5 kilos gave $8.5. So 1 kilo will give $3.4. Right? So now with that, let's rank the products, right? So which product should I produce first, guys? Which product should I allocate the resource first? The product that generates the highest contribution per limiting factor, right? So product Q2 is my most profitable product. Clear? So I should prioritize that first. Product Q2 is the most profitable product since it generates the highest contribution per limiting factor and should be produced first, right? So that part also we understood. Q2 should be produced first. Clear? Now check, guys. So this contribution per limiting factor. What is contribution per limiting factor? contribution generated by 1 kilo of material. In this example, contribution per limiting factor means contribution generated by 1 kilo of material. Clear? So now we know that since Q2 is the most profitable product, we need to prioritize and produce Q2 first. Now check the demand for Q2. What is the demand for Q2? Demand for Q2 is unlimited. Yes or no? Yes, demand for Q2 is unlimited. So if demand for Q2 is, if we are going to prioritize Q2 first, right? Q2 is the most profitable product. So if we are going to prioritize Q2 first and the demand for Q2 is unlimited, what does it mean, guys? What does it mean? It means that we should only produce and sell Q2. We should only produce and sell Q2. Why is that? Because Q2 is my most profitable product and the demand for Q2 is unlimited. We can sell any amount we want. So therefore, we should only produce and sell Q2. We should not produce and sell Q1. We should only produce and sell Q2. Is that clear? Did everyone understand that? Any questions? Right? Since the demand for Q2 is unlimited, Q PLC should only produce and sell product Q2. Clear? Unlimited, and it is the most profitable product. QPLC should only produce and sell Q2. Clear, guys? Any questions? Right. So in that case, guys, if we produce and sell only Q2, right? If we produce and sell only Q2, 1 kilo of material generates a contribution of how much? 1 kilo of material generates a contribution of how much? $3.4, isn't it? $3.4. So what is the definition of shadow pricing, guys? Shadow pricing means how much contribution will one extra unit or one extra unit of a resource generate. Now in this case, the resource is material. So how much contribution does 1 kilo of material generate, guys? So if we are only making product Q2, 1 kilo of material generates a contribution of 3.4. Why? Why is that? Because contribution per unit of Q2 is 8.5, and to make 1 unit of Q2 we need 2.5 kilos. So if 2.5 kilos generates a contribution of 8.5, 1 kilo will generate a contribution of 3.4. 8.5 divided by 2.5, right? 3.4. So 3.4 is the contribution per limiting factor. In other words, this 3.4 is the contribution generated by 1 kilo of raw material. Clear? So what is the definition of shadow price? How much contribution does 1 unit of a resource generate? So that is 3.4. Clear? Clear, guys? So any questions on that? Yeah. The contribution earned by 1 kilo of material, contribution per limiting factor. It's $3.4 per kilo, which is the same as shadow price. Therefore, the shadow price per kilo when only product Q2 is produced is $3.4 per kilo. Answer D. Clear? Answer D. Any questions, guys? Any questions? Please go through it and ask any questions, guys. Yeah. Okay. Right. So with that, guys, we have completed linear programming, right? Big topic. We have completed it. So in the next class, we will start off with the next topic. So recordings, guys, you have to send a message to Anushan, right? Either he has dropped that in the group also, he has sent a message in the group also. For you to collect the previous week's recordings, you have to send a direct message to him, right? Then not in the group, but separately on WhatsApp to him, message requesting the recordings, then he will share it with you. He will not share it on the group. Okay, so you have to send a message to him, right? So next week, let's start off with the next topic, risk and uncertainty. Okay, so I will see you all next week, guys.